we're going to talk about some thermography, but specifically the Titron as well, and specifically pattern analysis. So this is some stuff that I think that you guys, or I guess I don't think anyone's really talking about this. So I'm really excited to go over some of this stuff as well with BK here. So I like to break this down into 3 basic categories, okay? So like if someone is talking about thermography, or if they're questioning you about it, or if they want to know, and you want to just take like a logical perspective on like what thermography is, then you're going to ask some basic questions. So these are 3 questions you have to ask to understand pattern analysis. Number 1, what does thermography directly measure? I get that a lot, right? Because we say it gives us a direct look into how the nervous system is functioning, but what does it directly measure? Number 2, how does a pattern indicate neurologic interference? And that is a question I think probably 95% of chiropractors, upper cervical chiropractors, but also just chiropractors that use thermography cannot answer that question. So we're going to give you the exact way to answer that question today, which is awesome. How is pattern analysis objective? I get this one sometimes as well. How is that any more objective than anything else that we're doing? We're going to break that down as well. What does thermography directly measure? He kind of went into it a little bit already, and we'll just kind of go brief into it because I don't think it's that important. I know you guys probably know quite a bit about it as already. The Titron specifically, dual probe infrared thermographic scanner, measures heat bilaterally. Infrared instrument allows measurement deep capillary beds by bypassing surface temperature, reducing the variability within the scan as well, which is different than thermocouples in that reason, or for that reason, because it's going to be more constant, okay? So the tool itself is going to be more objective because we're able to reduce that variability by measuring the deep capillary beds. All right, so here's some cool information as well. We already went over this study the other day, but this is how does pattern analysis indicate neurologic interference? We're going to start diving into that right now, okay? And this is, I think, the number 1 most important thing. If you guys had to take away anything from the thermography talk, I'm not just saying it because I'm talking, but I'm just saying it because I think this is something that people are going to be like, well, how do you get from heat to neurologic interference, right? Here's how. All right, although barostat, hypothetical entity, functional baroreflexes have been worked out in some detail. Baroreceptive afferents traveling the glossopharyngeal vagus nerve synapse in the nucleus solitary tract medulla oblongata of the brainstem. Subsequent relay stations in the reflex arc include A1 noradrenergic neuron, caudal, ventral, lateral medulla. Nucleus ambiguous, major source of descending cardiovagal flow, and the rostroventral medulla, a major source of descending input to the sympathetic preganglionic neurons. High centers, such as the paraventricular nucleus of the hypothalamus, modulate response characteristics of the medullary barostat as well. Baroreflex pathways, also a center of the brain, might modulate consciousness, vigilance, nociception, emotion. Indeed, more than 30 years ago, it was proposed high blood pressure reduces reactively to noxious information via baroreceptive activation, okay? And we talked about that yesterday. Remember we were talking about in the neurology section as well, how we go from PVN to the RVLM to the IML to pregang sympathetic trunk, and then out to the end organ, right? So this study is very important in breaking that down. And the funny thing is, we were diving deep into the pathways of how this works. And literally I was like we're going crazy, like just research, and I'm like, okay, we're going to find some connections with these areas. We know they're connected. How are they connected? And this pathway come up. So the funny thing is, this pathway actually was made before we found this study, which was kind of cool. So it led us in the right direction there, which was awesome. So BK, if you want to go ahead and start here.
So you guys saw this yesterday, but that was the big staple to remember. Obviously, this is like the generalized, like summary version of it. And that study, and there's lots of other research out there just talking about the anatomical structures in the body. That's just like one of them. But this is like the general one that I would suggest to try to remember like in your time at school and stuff, especially if you plan on using thermography, because I mean, that's like a really good pathway for how that works, especially once we get into negative feedback loops as well, because just memorizing this isn't even enough, but you're already going to be way ahead if you do. And then the next part with feedback loops that Dr. Simmons is going to get into is going to like take it one step further as well.
Yeah, absolutely, for sure. So let's just recap this again, okay, guys? Did anybody look at it or try to remember any of it? PVN, paraventricular nucleus of what? Where's this at? Hypothalamus. Yep. That's right. PVN, the paraventricular nucleus of the hypothalamus. Okay, it sends information to the, what is this? The RVLM. What is that? Ventral, lateral, medulla.
Oh.
That's right. Boom. And that information then goes to, what is this? The intermediolateral nucleus. And where are those cell bodies located? Spinal cord. That's right. Exactly. Lateral horn, spinal cord. And then that gets sent to the pregangliotic sympathetic neurons, which then obviously goes sympathetic chain, blood vessels, and that's how we come to the conclusion of pattern analysis. But wait a second. I'm still not understanding. How are we going from here to here to here to here to here, and then all of a sudden pattern analysis? Where does that come from? I really had to dive and question my own assumed beliefs of what pattern analysis was to really come to the conclusion of pattern analysis as here. And it's actually so much stronger than I even realized. And that's what tends to happen, right? If you know, obviously truth cannot be destroyed, right? So if we're able to dive into truth and try to break it down, what's going to happen? It's going to prevail. That's what's going to happen. So let's go. Oh. Okay, here we go. How does pattern indicate neurologic interference? Okay, so what is a negative feedback loop? Do you guys know? Or where's your knowledge on that?
Something happens, it's the body's way of calming it down.
Okay, yep, good. Any other thoughts? Just curious. Mm-hmm.
Hormones. Something goes when it goes high, that is it at the end.
Yes.
It's the opposite of positive.
Yes, yep.
Too much of something, positive
Yes.
feedback, too little.
Boom, yeah, there you go, exactly, right. So I like to give a normal example of like, if we went outside for lunch, right? We got a little bit hot, our body is gonna cool ourselves down. That's a negative feedback loop. For example, if there was a woman and she was going to give birth, she obviously, like what happens, her water breaks and then all of a sudden everything starts dilating and then relaxin is released. And then once the baby comes out, then all of a sudden now oxytocin is released again for the second wave, which then causes the letdown of the milk, right? And then obviously, so the point is, it's like step, there's different things going on. It's a whole completed cycle, whereas this is like a circle, if you will, negative feedback, okay? So that's kind of how it works here. We got the stimulus, and that goes down to the sensor, and that goes to the control, that goes to the effector, and the effector then goes back up. It reevaluates then, because if this ends up fixing the issue, then the stimulus will not be stimulated again, if you will. Or excuse me, yeah, exactly. It won't be able to stimulate it again. For example, if I go out in the heat here and this cycle is going on, boom, 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 and then the sun goes away, this cycle ends. Does that make sense? Okay. So here's a body temperature exceeds 37 degrees Celsius. What's that in like in Fahrenheit? Do you know? I didn't know if maybe you know. Okay. I don't know. I figured hot, but I don't know. So anyways, what happens here? Nerve cells in the skin and brain. It's the sensor there, right? Temperature regulatory center in the brain, which we like to correct this. It's brainstem, is it not? Hypothalamus there, right? It's part of the brain, but whatever. We're splitting a hair. Then the sweat glands throughout the body are going to start sweating. Boom. And then this stimulus happens again, and this keeps happening. Negative feedback loop until this changes, okay? So I'm just trying to get you guys to think about these loops, because this what happens is people will think that every single situation is so different, and they'll think too many times that, oh, well, if you're in a negative feedback loop, I want to be careful of my words here, but if you're in a negative feedback loop, it's a bad thing. It's not a bad thing. Negative feedback loops keep you from essentially dying, right? Because if this loop didn't stop, what's going to happen? I'm going to get too hot and I'm going to die. Go ahead.
Yeah, I was going to say that's also important as a chiropractor, because you got to know the difference between those negative feedback loops that are good ones and bad ones, aka subluxation, right? That's a bad one where you need to intervene and adjust somebody, versus if it's one that's not neurological interference, then that's not a good indicator to go in and put an adjustic thrust into somebody, right?
Yes,
So it's
absolutely.
important to be able to be deductive with your analysis via the thermography.
Yes, and not everything that's a pattern is bad. I want to say that as well, because think about this for a second. If I have a pattern of going to bed every single night, is that a bad pattern? No, that's a good pattern, right? That's a negative feedback loop, right? So the stimulus was that I needed to sleep, right? Okay, so the point that I'm making is we're understanding the roles of negative feedback loops here. Okay, now let's go a little more in depth on it. This was the baby one. This was like the first try or first quarter, and then we're like second quarter, and then this is like third quarter, and they're like, okay, anyway. That was like when they say the mitochondria, like the powerhouse of the cell, and then all of a sudden you're in like microbiology or biochem or whatever, and then they're like all this stuff, and you're like, I don't even know. So this is what we're doing here. Okay, so we got regulator, right? Which is, oops, my bad. So we got regulator, which is going to be a little bit different here. And we got homeostasis, okay? And then these little green arrows can indicate some other stuff. You guys can read this study if you want. It goes super in depth with negative feedback loops. But I'm going to give you guys a little general thing here. So we have the effector. Do you guys remember what the effector actually is? We talked about back here? That's actually the physiologic function, okay? Go back here. So the effector, the physiologic, like I like to think of this as almost like matter, right? The actual matter of the body, okay? Monitored variable, and then perturbation, or however you want to say that. Afferent information, homeostasis goes back in this loop, okay? So this is a little bit general, or excuse me, less general. This is more like basic, what they're going to probably learn at like normal places, and then obviously you go to chiropractic college and everything's like 10 times more in depth. So nerve skin, blah, blah, blah. So these are like different words here for it, okay? But the effector is still the exact same. This is like the matter, okay? Going back here, the effector, sweat glands throughout the body, okay? Boom. Monitor variable. So in order to maintain this homeostasis, it goes in this cycle, okay? So now negative feedback loops, I want to reiterate, are good, okay? Are they always good? Well, we're going to get into that. So an effector, what is going to affect the effector? Well, wear and tear can change an effector, right? Decreased efficiency. So if this cycle is not able to happen properly, that's going to change it. Time, like wear and tear, right? Genes, gene expression, resilience, environment, boom. This is going to change all of this, what? Matter, right? And that's going to affect it. What's another thing that might affect an effector? Can you think of anything as chiropractors? Maybe a subluxation, right? I know we started getting back into the school brain, and then all of a sudden we're like, wait, no, I'm just kidding. I know. So anyway, so I like to keep that in there. I like to almost draw a little, I should have done that. Subluxation. That'd been good. Okay, so when does pattern indicate neurologic interference? Or so how does pattern indicate neurologic interference? When there's interference with the what? What is this? Rostroventral lateral medulla. Where does that get input from again? Yeah, PVM, exactly. PVM, or paraventricular nucleus of the hypothalamus to the IML. So where's interference at? RVLM, IML. This is where an adaptive mechanism of a negative feedback loop is causing consistent sympathetic dilation and constriction. Okay? So this is super important. What was your question yesterday? Remember? Why don't we call it sympathetic? Remember that? This is because the negative feedback loop is going to be affecting sympathetics greatly. Okay? Now, don't be confused with the fact that the pressure or the interference of the neurologic structures, rather, is going to be affecting all autonomics. Okay? But what we're measuring directly, just like how we say we measure the blood vessels, are we just measuring blood vessels? No. But we're going to step back further, sympathetic, go back a step further, autonomics. When there is interference on a neurologic structure, what is the first? There's three things that become decreased. And in order, what is the first one? Do you guys know?
Mess right here.
Yeah, those would be neuromusculoskeletal class if you guys have that, or orthopedic class, or whatever you guys call it. First thing is autonomics. So you're right. But autonomics, okay? You guys, I don't have this in here, so maybe you should write it down too, just so you don't forget, because this is, I can cite it too. But autonomics is the first thing, okay? Second thing is sensory. Third thing is motor, okay? So now if someone comes into your office rather, and they have no symptoms, where do we think we're starting at in those three? They have no symptoms. Yeah, autonomic, exactly, because sensory hasn't been affected yet, right? Do you think they could be in pattern and have no symptoms? Absolutely. Do you think someone could have sensory deficit, have pain, or have sensory deficit, like a deficit to light touch, pinprick, all that crap, right? Think they could have that and have subluxation? Absolutely. Motor deficit? Absolutely. So it's important to know that, okay? Go ahead.
And the reverse of that too. If you touch somebody or palpate them, say, does it hurt here? Does it hurt here? Oh yeah, that hurts. It hurts. But does that mean they have pressure on the nerves and autonomics? Right? You can get adjusted, have no subluxation, and still have pain, right? You could have just went to the gym and your muscles are sore. So you could feel that sensory might be having issues, or it just feels like pain, so it feels like sensory issues going on, but there's no interference to the autonomics via you wouldn't find a pattern on them because you just cleared them. So that's where, like, when you break down this negative feedback loop, those three things he just told you, that's really huge for having it come full circle.
Yes.
Big light bulb.
100%. And another thing as well, just to go with that, some more philosophy, but if I'm palpating an area and it's not tender, does that mean there's no neurologic interference? Absolutely not. Because what if there's a deficit to light touch pinprick? It's the same thing, okay? So, negative feedback loop causing consistent sympathetic dilation constriction. If we establish that this negative feedback loop is caused from that interference, then all afferent and efferent signals will be altered, okay? That's the point. Because what goes through here? These three structures, PVN, RVLM, IML, every single thing is controlled by that, okay? Now, what about parasympathetic flow? We talked about that the other day, didn't we? Parasympathetic flow. Where's the nucleus of origin for the vagus nerve? Posterior, superior medulla. 3, 7, 9, 10. Right? And where does that information go? PVN. And then it comes out the jugular foramen, and then it lies anterior to the wing of the atlas and can get pinched in between the carotid sheath, right? So there's actually double there. We could talk about, I could do a whole 3-hour lecture on the vagus nerve. Go ahead.
Yeah, I was going to say another thing too. Anytime the sympathetics are altered, the parasympathetics are altered. It's
Yes.
like one doesn't rule over the other one. It's like, so anytime we're talking about this, is like the whole system's messed up. That's why, like we always say, the difference between chiropractors and medical mindset a lot of times is we don't look at the body as parts, we look at it as a whole, because it has to function harmoniously, right? Those principles, they were spot on way back before they knew all this stuff somehow. So
what does laboratory research do to chiropractic? It only what? Proves what we do, right? It doesn't direct it, it proves it. And that's exactly what this is right here, okay? I'll get a little philosophical on you guys here. But, all right, so let's go back a second here. Where were we just talking about? Oh, yes, so the parasympathetic flow. So if I got really scared all of a sudden, let's just take all this crap out of our head for a second. I got really scared. I'm scared. Sympathetics are flowing, okay? And then all of a sudden, my parasympathetics do what? They try to combat it. They try to come up. And then my sympathetics, if they drop, then what happens? This is something that we learned about as well. Pass out, right? That's why you pass out when you get scared. Sympathetics, boom, parasympathetics trying to match it, and then sympathetics go back down. Boom, my parasympathetics are, oh, boom, body wants to go horizontal to get more blood back to the brain, right? Okay, RVLM, IML control everything, including but not limited to hormones. So why aren't we talking about hormones? You talk about whatever you want. It's everything. Everything is controlled by the paraventricular nucleus from the RVLM, and then also IML as well, obviously. What is the most highly dense innervated organ structure from the sympathetic chain, or sympathetics in general? The adrenal glands, hormones, cortisol. Come on, let's go. Like, this is like everything. People are like, they think like, oh no, this is not whatever. It's all of it. It's every single thing. Digestion, of course, vagus nerve, sympathetics. Sympathetics do what to digestion? We'll talk about it in a second. Heart rate. Beta-1, androgenic nerve receptor fibers, right? Increase sinoatrial node and atriovestibular node. Enzymatic function. Tumor necrosis factor. What does tumor necrosis factor do? Inflammation, right? So even if somebody has, go ahead. I was just gonna say, if somebody has rheumatoid arthritis, can we help with that? Yeah. Because if the sympathetics are kicking on, and we got these androgenic nerve receptor fibers stimulating, going crazy, and they're not inhibiting tumor necrosis factor, the only neurotransmitter that can inhibit tumor necrosis factor there is acetylcholine, cholerogenic, however you pronounce that. Okay, so I think it's funny, people, there's a lot of upper cervical people, or even chiropractic people in general, like, we can't really help with that. We're not trying to cure it. But the body is so smart, and this is just surface level, guys. So let's just keep that in mind. Go ahead.
yeah, I was going to say, being advanced HIO knee chest, currently there's not a better way that we know of, and there might in the future. That's why it's advanced, and we're open to any ideas. But you might be wondering, why don't we just look at the hormones then to develop a pattern? Because if the RVL, M, and the IML control the blood vessels, and you're measuring that, why don't you do something else? Well, it's like, well, we could theoretically, right? But this is the least the most non-invasive way to do it,
absolutely,
right? In consistent, timely manner. You probably could take samples of hormones, Then by the time you do the
Enzymes,
the next one, it probably takes a while for that whole process. I don't know how they do syringes and
Absolutely.
the spins or whatever.
Yeah,
but
absolutely.
it would take a while.
100%. That's a great point. So when people say like, why do you use pattern analysis? Why do you use that? Well, we're using pattern analysis with thermography. That's it. There's so many other ways you could do pattern analysis.
Yes.
Okay. So yeah, go ahead.
Yeah, I was going to say, just like with hormones and stuff like that, there probably is ways to do it, but it's invasive. Like you'd have to poke them with something or whatever, and that's against chiropractic philosophy a little bit as well. So there might be a way to do that in the future really effectively without being invasive, but as of now, this is like the gold standard, we'd say, of developing or determining neurological interference via pattern.
Absolutely. So this is, I can see you thinking already, but this is getting super, and this is like, we go back, we talk about this all the time. We're like, did BJ know this? Did BJ understand this and then get this? Did he get that? I don't know. I don't want to like, he's so smart. I would think no, but he was freaking right about this. I don't know how, but he was. Yeah. But that's once again, right? The laboratory studies only prove what chiropractic does. He didn't need all this to know.
Yeah.
Right? He knew the nervous system controls everything. Okay. Now, remember seeing this yesterday? Androgenic nerve receptor fibers in the autonomic nervous system. Wait, sympathetic nervous system? No. Autonomic nervous system, right? We got alpha 1, alpha 2, beta 1, beta 2. What are the two important ones that we need to know? Or actually, let's go through these real quick. One time, BK, you want to go for it?
Yep. So alpha 1, they will increase smooth muscle in the blood vessels. So increase alpha 1.
Alpha 2 right here is going to decrease smooth muscle activity where? GI. Okay. So could you get a pattern in the GI technically? Sure. Why not? I mean, does that make a lot more sense, or is it that easier to do than pattern analysis for thermography? No. That's why we don't do it, right? All right.
So again, beta 1, so the ones are increasing. So beta 1 increase SAAV nodes of the heart.
Absolutely. So beta 2 is going to decrease smooth muscle activity in blood vessels, rather. So the two I want you guys to really know, alpha 1 and beta 2. Now, if you guys, there will be a day, if it hasn't happened here at school, it's happened to us a million times at school, but if it doesn't happen here, there will be a day where a medical doctor will say, so like, how do you, like, you're talking about the nervous system, how do you know about the nervous system? And that's going to be the day that you will either get humbled or they're going to get humbled, okay? And all you have to say is, oh, alpha 1 and beta 2 androgenic nerve receptor fibers, which come from the intramedullary nucleus, which come from the RVLM, which come from the paraventricular nucleus, is what stimulates blood vessel change, decrease and increase. You remember learning that, don't you? They don't remember learning that. We barely remember learning that just because we went over it. All you got to say. No more questions asked. And if there are, I mean, it's like, it's all here. It's easy. Go ahead.
Now, just get ready for this. This is like the first half of pattern analysis. This is more just neurophysiology.
Yeah, this
now
is physiology.
The analysis of it is like what's super important as well. So this is like the equivalent of like having x-rays and then looking at x-rays chiropractically.
Yes.
Because this is just how the body's functioning. Now it's like, what do we do with this knowledge of alpha 1, beta 2? And that's where I think it's going to get really cool.
Yes, and I'm going to
cool.
recap this one more time because I can guarantee you there is no other group out there that is even coming anywhere near as close to the pattern analysis as we are right here, okay? So I want you guys to really, and feel free to share this too, you know what I mean? Like I want you guys to, I don't want it to be like, no, we can't tell you this stuff that we know. No, tell them, I don't care. I mean, obviously, like, I don't want like sending the notes all around, but like, you know what I mean? Tell them whatever, like show them what you know, okay? All right, so how does a pattern indicate neurologic interference? Let's actually answer that question here. Alpha 1 does what? Increase. Beta 2 does what? Okay, so what do we say? X out these ones for now, okay? So look at these areas right here. What are you guys all familiar with this diagram or no? The bar graph? Okay, great. So obviously we don't use this for pattern analysis, but I'm just demonstrating something here real quick. The left side, is it colder or hotter than this side? Say that again. Cooler, right? Does it mean that, well, we'll get into that in a second, but it just means it's cooler than the side, right? In reference to what? The other side. So there's a couple possibilities. It could be normal, could be perfectly normal on that side, and this side could be what? Dilated, which would be beta 2, right? That's a possibility, is it not? Or This side could be constricted, alpha 1, and the right side be what? Normal. This side could be constricted, and this side could be dilated. Understanding that? And in this scenario, it's all going to demonstrate this neurologically. There's 3 different neurologic ways that it could demonstrate this. Go ahead.
I was going to say too, because this is just saying the difference it's in reference to. So
Yes.
it's not like you can't just say for sure, oh, alpha 1 must be happening right now on that side, and it's just in reference to the other ones. That's why he's saying it could be any of these, because when a really way to understand it better, which we'll show is the graph, is like always doing the change in the blood vessel circles, and that helps you see, oh, this one's bigger, that's why it's that way, which we'll show you.
Yes.
That's how you really get a good idea of it too.
So I just want to make sure we understand this before we move on. Does everybody understand this concept? Okay, great. And this goes for every single little tiny piece here. Every single one. Okay? This blows my mind that some people don't. They think like, oh, the rest of it doesn't matter. Okay, so here we go. Bar graph. And then here's like what I made, like a little graph that would like match that, right? You guys see that there? So this is the same thing as like this side would be hotter, which could be any of those 3 combinations, right? Boom, right there. Looks like that. Okay. Got alpha 1, alpha 2, beta 1, beta 2. So those combinations, again, obviously we want normal, normal. That's what we want. But it could be normal and dilated, beta 2. It could be constricted and normal, which would be alpha 1 on this side. It could be constricted and dilated, beta 2. Understanding? We're good? Okay, it's important to know all three of these levels will lateralize to the right, even though they are different what? Combinations. Okay? So if they're different combinations, that doesn't mean that it's a pattern. If I only ever looked at this side, I could get 3 different, actually I could get unlimited amount, because what if it was a little bit constricted and a little bit dilated, or a little bit constricted and normal, or really constricted and normal? It's unlimited. It's literally unlimited. So we could get a bajillion combinations at just one level. Okay, that's what is important to understand. Is it mad or no?
Yeah, I was going to say, once we get into adapting as well, you could get a rope on somebody, and how you really know they're adapting is because we don't even know for sure if it's normal, all the way down balance to the spine. It's comparative, right?
Yes.
So you could have some segments that are both dilating really good now because that's what the body wanted, was them to dilate. And then the level below it, they could both be constricted, but in reference to each side at both levels, it's going to represent a rope, because now comparatively they're good. But that's showing it's changing, because it's like alpha 1 up here, beta 2 down here. They're different. It's not stuck in that negative feedback loop doing the same thing. So it's different now, even though it's a rope, but it's the same. Because I think we like to think too much that a rope just means it's normal, even on both sides. Well,
like that.
It is even balance on both sides, but we don't. It's adapting. It's changing.
Yes, it could be 2 big
So
red
much,
ones,
yeah.
right? Exactly. So we just want bilateral equality in a way. It doesn't have to be bilateral. Does that mean that it's, if it's not like that, does that mean it's not clear? No, doesn't mean that. But we do know that when we have this negative feedback loop, like this, it's lateralizing this way, and it's consistent every single time, and we'll talk about it here in a second, but that we do know that that means it's a negative feedback loop, which means that there's an effector issue. So let's break it down one more time. Let's say this is a graph here. Goes like this, and it rips out to the right there. We got normal. We got a little bit to the right, a little bit to the right, a little bit to the right. Same thing, right? That's going to demonstrate the graph. Since there are at least 3 basic neurologic combinations to a break, you must run scan over multiple levels to ensure there is a pattern of interference. Over what? Multiple levels. Because if it's one level, how many basic combinations are there at one level? 3 basic ones. And then how many after that, once you start breaking really constricted, really big, minorly constricted, and super small, you know what I mean? Just barely bigger. Infinite combinations. Okay? If you only compared one level to itself, it's a 50-50 shot the delta will lateralize the same side. Think about that for a second. That's a scary thought. So if I say, if I'm doing like mono level pattern analysis, oh, it's right break every time at this level. That's infinite combination. It's a 50-50 shot. So it's infinite combinations divided by 2. That's your 50-50 shot. We don't want that. Pattern analysis will ensure that they're in a neurologic negative feedback loop of interference. Okay? We need a couple levels. If it's the same every single time at multiple levels, that's not a coincidence. It's not a coincidence. What is a coincidence? That it's the exact same breaks, the same size breaks, same differential break at multiple levels every single time. That doesn't change throughout their life. I still have the same pattern of when I was born.
Yeah, that's what I was going to say. From a baby to an adult, that's the pattern right there. And that just goes to show you it's not just random. It's like it's reproducible.
Yes,
So.
absolutely. Because it's not just the break to the side; it's the size of the break. Go ahead. Yeah, absolutely. Yeah, and think about this too. Biomechanically, a baby is completely different too. Are they upright? No, right? So they have completely different biomechanics as well. So I like to think about it like this. That's why when we talked about, remember that day, the first day we said or like people think most of the time the atlas goes one way, the head tilts the other way. In babies, that's kind of the case because they're not upright. So we don't have all this change. And are their muscles strong enough to actually change? Is the vestibulospinal tract strong enough to actually change the extensors and flexors in the spinal column to actually change the biomechanics? It's not. So that is a little more consistent there. Okay. Good question though.
And another thing I'll add with that too is it's already a given, and especially the upper cervical world, that as people age, the care is going to get more accurate and consistent. Because do you x-ray babies? No, right? So once they get to the age where you can x-ray them, boom. Once they get to the age where their neck is full pattern, it's just going to get better. So
absolutely.
Yeah.
100%. Love it. All right. How is pattern analysis objective? Because I feel like we've answered this question pretty well at this point. We've kind of beat it in the ground. So how is pattern analysis objective? We've already discussed that the inter and intra reliability of the titron and pattern analysis is statistically significant. Oh, we didn't yet, but it'll come up here in a second. We have a lot of studies. Have you guys seen the intra reliability studies, titron? I think they're in here. So we'll get them in here, or they are in the notes rather, but we just probably haven't gotten there yet. There's a lot of research with intra and inter reliability. You guys know the difference, right, between docs and within themselves. It's the highest, is the highest. So we're not even talking about that. Let's back out of there. We will talk about rather how the reliability is statistically significant. But is the tool itself objective? That's something I want to think about here for a second. Because if I'm doing, I don't want to say like leg checks, but let's say leg checks for an example. Leg checks are great. I'm not saying there's anything wrong with them. But is that itself objective? Maybe the I haven't seen any research where the inter and intra reliability is consistent statistically, but let's say it was. Does that mean it's still objective? No, it doesn't still mean it's objective, right? Because there's a subjective component that can be, there's an art component still, and the same thing with the titron. Can you run a titron scan and it's going to be inconsistent from him and me? Absolutely, if someone doesn't know how to use it. But does that mean it's not an objective tool? We'll get into that. The objective nature of blood pressure cuff is not dependent on the user's ability. It's the machine itself because of the natural laws discovered in nature. Okay? You have something to say about that real quick or no?
Yeah, a lot of times I'll hear, people will say it's subjective, right? Like pattern analysis, titron, and I don't know what part specifically they think is subjective or if they just don't understand what it means, if it's subjective or not. But it's like getting a ruler and giving it to a 5-year-old and being like, measure the length of that. And they come back and they tell you something that's an inch long is 8 inches, right? It's like, that doesn't mean measuring something is not objective anymore just because they don't know how to use the tool, right? If I showed one of my family members who's not a chiropractor an APOM and said, find the lateral mass, does that make x-rays all of a sudden trash, throw it out the window? No, they don't know. They're not trained in using the tool, just like how you have to be trained in the titron, trained in taking an x-ray, get proper images, proper analysis. So
exactly.
Reproducibility is high when you're trained well. That does, the thing that makes it objective is that it's measuring something, it's measurable, and it takes your opinion out of it.
Absolutely, for sure. Like if I had a robot do it and it did it the exact same way every single time, I'm not going to get a different result, right? So that makes the tool objective. Same thing with a blood pressure cuff. Same thing with heart rate monitor, right? It takes the subjectivity out of it. So if anybody says, well, that's subjective. The objective nature of blood pressure cuff or titron or whatever you want to put in there is not dependent on the user's ability. It's dependent on the tool, okay? All right, so let's go back through these 3 questions here. What does thermography directly measure? Well, we got that. What does pattern indicate, or how does pattern indicate neurologic interference? We really answered that. And how does pattern analysis objective? I feel like we answered that. Do you guys have any questions about that kind of stuff? Because I feel like titron sometimes is one of the scary topics for upper cervical people, chiropractic, anyone that uses a Titron or any kind of thermography, that's where I've heard people say this is where I feel like X-ray. I know that's what it is. Adjusting like I know or whatever. My palpation is this, but Titron, I'm like, I get it. You want to be adapting, but like I don't really get it. You know what I mean? So you guys have any questions about that at all? Anything off the top of your head or anything you've ever heard?
Well, that's mostly the interpretation. It's a clinical interpretation.
Yeah.
So you want the pattern.
Yeah.
A lot of people get nervous about that.
Mhm.
Oh, well, it looks a little different.
Yeah,
Absolutely. And one more thing too that he'll get into this probably at some point in here. But as far as scans go and how we do in our office is people come down, sit down right away, and we scan them. We don't even give them time to adapt. Why? Because if they're in that pattern and it's 3 different combinations for each single level or infinite combinations, but 3 basic combinations, and if we scan them, they're in pattern, that's not an accident. They didn't sit down here and not adapt to the room temperature yet and be in pattern on accident. Because it's not an accident. Do you understand what I'm saying? There's infinite possibilities.
Yeah.
So if they're not in pattern, we do pre-rest them. But if they're in pattern, we adjust them. Does that make sense? And that's more of a that's like a philosophical or like a personal choice. You know what I mean? If you want to pre-rest, that's great. Do whatever you want. You know what I mean? If you want to rest for 2 hours like DJ did in the clinic, go for it. There's nothing wrong with that. So,
and to add to that too, if you're worried about them having to acclimate and that changing whether they're in pattern or not, if they're a little bit warmer in general, the difference, the delta T with those multiple levels is still going to represent a pattern, whether their pattern is exaggerated or reduced. It's not adapting properly. Their body's warmer overall, but again, we're looking at both sides.
comparative.
The pattern overall, so it's not going to change. Unless they flatline or whatever, of course, you're going to have to pre-rest them or let them acclimate.
Yes.
But we're not talking about that. We're talking about like, is it going to change the pattern? It shouldn't, right?
Yes.
So.
Yes. And if you have variability, then don't adjust and just wait.
Yep.
Okay? You can always wait. You can always run another scan. That's what I like to say. Right?
That's
Okay.
a few 1% of time or